According to NFPA 70, the National Electrical Code, there are requirements for disconnecting means for transformers operating under 600 volts, specifically related to dry-type transformers. Section 450.13 states that disconnecting means shall be provided to disconnect the transformer from all ungrounded conductors. This means that you must have a way to completely isolate the transformer from the incoming power supply. This ensures that the transformer can be de-energized for safety during maintenance, repairs, or in emergency situations. Section 450.13b elaborates on the location and operation of this disconnecting means. It states that the disconnecting means shall be in sight from the transformer, or it shall be capable of being locked in the open position. The primary intention is to provide a readily accessible and visually verifiable method for ensuring the transformer is de-energized before any work is performed on it. Being in sight means that the disconnecting means should be visible from the transformer's location without having to walk a significant distance or navigate through obstructions. This allows personnel to visually confirm that the transformer is indeed disconnected before commencing any work. The code recognizes that there may be situations where having the disconnecting means in sight of the transformer is not practical or feasible. This could be due to the physical layout of the facility, the location of the transformer within an enclosure, or other design considerations. In such cases, the code provides an exception. The disconnecting means can be located remotely, provided it is capable of being locked in the open position. This lockable feature is crucial because it ensures that the disconnecting means cannot be inadvertently or accidentally closed while work is being performed on the transformer. The ability to lock the disconnect in the open position provides a positive means of isolation, preventing the transformer from being re-energized until the lock is removed. The lock should only be removable by the person or persons performing the work, thereby guaranteeing their safety. In summary, the code mandates a disconnecting means for transformers under 600 volts to isolate them from the power source. This disconnect must either be within sight of the transformer for easy visual verification or be lockable in the open position to ensure safety during maintenance or emergencies. These requirements exist to protect personnel and prevent electrical hazards associated with working on or near transformers. It is imperative to adhere to these code requirements during the design, installation, and maintenance of transformer systems to ensure a safe and compliant electrical installation. Always consult the latest edition of the National Electrical Code and consult with a qualified electrical professional for specific applications and interpretations. Firstly, ensure that the disconnecting means is properly rated for the voltage and current of the transformer circuit. The disconnecting means must be capable of interrupting the full load current and the available fault current at the transformer location. Secondly, the disconnecting means should be readily accessible and clearly labeled to indicate its purpose and the equipment it serves. This ensures that personnel can quickly locate and operate the disconnect in case of an emergency. Thirdly, if the disconnecting means is not within sight of the transformer, make sure that it is equipped with a reliable locking mechanism and that a clear lockout/tagout procedure is in place. This procedure should outline the steps for de-energizing the transformer, applying the lock, and verifying that the transformer is indeed de-energized before commencing work. Fourthly, regularly inspect and maintain the disconnecting means to ensure that it is in good working condition. Check for any signs of damage, corrosion, or loose connections, and replace or repair any defective components promptly. Fifthly, provide adequate training to all personnel who may be required to operate or maintain the disconnecting means. This training should cover the proper operation of the disconnect, the lockout/tagout procedure, and the potential hazards associated with working on or near transformers. Ignoring these requirements can lead to serious consequences, including electrical shock, arc flash, equipment damage, and even fatalities. By following these guidelines, you can significantly reduce the risk of electrical accidents and ensure a safe working environment. Remember, the National Electrical Code is a minimum standard, and it is always advisable to exceed these requirements where possible to enhance safety and reliability. Always consult with a qualified electrical professional to ensure that your transformer installations comply with all applicable codes and regulations. The specific requirements related to transformer disconnects are designed to protect individuals from electrical hazards and ensure the safe operation of electrical systems. Section 450.13 A and B of the National Electrical Code are particularly important in this regard. Section 450.13 emphasizes the necessity of having a readily available means to disconnect the transformer from all ungrounded conductors. This ensures that the transformer can be completely isolated from the power source, preventing any accidental energization during maintenance or repair work. Without such a disconnecting means, workers could be exposed to dangerous electrical currents, potentially leading to severe injuries or even death. Section 450.13b further specifies the location and characteristics of the disconnecting means. The requirement that the disconnect be in sight from the transformer aims to provide a clear and immediate visual confirmation that the transformer is de-energized. This eliminates any ambiguity or uncertainty about the transformer's status, reducing the risk of accidental contact with live electrical components. If the disconnecting means is not within sight, the code mandates that it be capable of being locked in the open position. This provision is crucial for preventing unauthorized or accidental re-energization of the transformer while work is in progress. By locking the disconnect, workers can ensure that the transformer remains de-energized until they have completed their tasks and removed the lock. The exception for lockable disconnects recognizes that in some situations, it may not be feasible or practical to have the disconnect within sight of the transformer. For example, in large industrial facilities, transformers may be located in remote or difficult to access areas. In such cases, a lockable disconnect provides an alternative means of ensuring worker safety. To comply with these code requirements, it is essential to select the appropriate type of disconnecting means for the specific transformer installation. The disconnect must be rated for the voltage and current levels of the transformer circuit, and it must be capable of safely interrupting the flow of electricity in the event of a fault. Additionally, the disconnect must be installed in a location that is readily accessible and clearly marked. Workers should be trained in the proper operation of the disconnecting means and the lockout/tagout procedures that must be followed before working on or near transformers. Regular inspections and maintenance of the disconnecting means are also crucial to ensure that it remains in good working condition. Any damaged or defective component should be replaced promptly to prevent potential hazards. Furthermore, it is important to consider any local codes or regulations that may supplement or modify the requirements of the National Electrical Code. Local authorities may have specific requirements for transformer installations that must be followed. In conclusion, the requirements for transformer disconnects in Section 450.13 A and B of the National Electrical Code are essential for ensuring worker safety and preventing electrical hazards. By understanding and complying with these requirements, you can help to create a safe and reliable electrical system. Furthermore, it's important to elaborate on the practical implications and considerations when implementing these requirements. The choice of disconnecting means is not just a matter of code compliance, it's also about ensuring the safety and efficiency of operation. Disconnects come in various forms, including switches, circuit breakers, and fuse disconnects. The selection should be based on the transformer size, voltage, current rating, and the specific application. A switch might be suitable for smaller transformers where frequent switching is not required, while a circuit breaker offers overcurrent protection in addition to disconnecting capabilities. Fuse disconnects provide an added layer of protection against short circuits and overloads. The location of the disconnect should be carefully considered. While the code allows for a lockable disconnect as an alternative to being within sight, placing the disconnect within sight is generally the preferred approach. This allows for immediate visual confirmation of the transformer's status, which can be crucial in emergency situations. The disconnect should be easily accessible, even in adverse conditions, such as during a power outage or in inclement weather. The labeling of the disconnect is also critical. It should be clearly marked to indicate the equipment it serves, the voltage and current ratings, and any relevant safety information. This helps to prevent confusion and ensures that the correct disconnect is used in any given situation. Lockout/tagout procedures are an integral part of transformer safety. These procedures involve energizing the transformer, locking the disconnect in the open position, and placing a tag on the disconnect to indicate that it is not to be re-energized. Only authorized personnel should be allowed to perform lockout/tagout procedures, and they should be thoroughly trained on the proper steps to follow. Regular inspections of transformer disconnects are essential to ensure their continued reliability. Inspections should include checking for signs of damage, corrosion, loose connections, and overheating. Any issue should be addressed promptly to prevent potential failures. Maintenance should be performed in accordance with the manufacturer's recommendations. This may include lubricating moving parts, tightening connections, and testing the disconnect's operation. The use of personal protective equipment, or PPE, is crucial when working on or near transformers. PPE includes items such as safety glasses, gloves, and arc-rated clothing. The specific PPE required will depend on the task being performed and the potential hazards involved. Training is key to ensuring that personnel are aware of the hazards associated with transformers and the proper procedures for working safely. Training should cover topics such as electrical safety, lockout/tagout procedures, and the use of PPE. Refresher training should be provided regularly to keep personnel up to date on the latest safety practices. Compliance with the National Electrical Code is not just a matter of following the rules, it's about creating a safe working environment for everyone. By understanding and implementing the requirements for transformer disconnects, you can help to prevent accidents and ensure the reliable operation of your electrical systems. It is equally important to understand the specific language used in the National Electrical Code, particularly sections 450.13a and b, and how it applies to real-world scenarios. Section 450.13a uses the phrase disconnecting means shall be provided. The word shall indicates a mandatory requirement. There is no room for interpretation or deviation. A disconnecting means must be present to isolate the transformer from ungrounded conductors. Ungrounded conductors refer to the live or hot wires that carry electrical current to the transformer. This section ensures that there is a dedicated mechanism to cut off power to the transformer when needed. Section 450.13b introduces the concept of insight from the transformer. This means that the disconnecting means must be visible and within a reasonable distance from the transformer. The intent is to allow a person standing at the transformer to clearly see the disconnect and verify its position. The phrase capable of being locked in the open position is crucial for situations where the disconnect is not within sight. This requires a mechanism that can physically prevent the disconnect from being closed, typically through the use of a padlock or similar device. This prevents accidental or unauthorized re-energization of the transformer while work is being performed. The exception for lockable disconnect is not a loophole to avoid placing the disconnect within sight. It is intended for situations where physical obstructions, distance, or other factors make it impractical to have the disconnect readily visible. In such cases, the lockable feature provides an equivalent level of safety. It's important to note that the disconnecting means must be properly rated for the transformer's voltage and current. Using an undersized disconnect can lead to overheating, failure, and potentially hazardous conditions. The disconnect should also be suitable for the environment in which it is installed. For example, in damp or corrosive environments, an M4 X-rated disconnect may be required to protect it from the elements. Regular maintenance of the disconnecting means is essential to ensure its reliability. This includes checking for loose connections, corrosion, and any signs of damage. The disconnect should be operated periodically to ensure that it functions smoothly. Lockout/tagout procedures should be strictly followed whenever working on your transformers. This involves de-energizing the transformer, locking the disconnect in the open position, and placing a tag on the disconnect indicating that it is not to be re-energized. Only authorized personnel should be allowed to perform lockout/tagout procedures, and they should be thoroughly trained on the proper steps to follow. In addition to the National Electrical Code, local codes and regulations may also apply to transformer installations. It's important to check with the local authorities to ensure compliance with all applicable requirements. Ignoring the requirements for transformer disconnects can have serious consequences, including electrical shock, arc flash, equipment damage, and even fatalities. By understanding and implementing these requirements, you can help to create a safe and reliable electrical system. Furthermore, consider the practical applications of these code requirements in various scenarios. In a commercial building, a dry-type transformer might be located in an electrical room to step down the voltage for lighting and receptacle circuits. The disconnecting means, typically a circuit breaker, would be located in the same electrical room within sight of the transformer. The circuit breaker would be clearly labeled to identify the transformer it serves. In an industrial facility, a larger dry-type transformer might be located in a separate enclosure or vault. Due to space constraints or other factors, the disconnecting means, perhaps a fuse disconnect switch, might be located outside the enclosure. In this case, the disconnect switch would need to be capable of being locked in the open position, and a robust lockout/tagout procedure would be in place. In a residential setting, a smaller dry-type transformer might be used to power low-voltage lighting or other equipment. The disconnecting means, often a simple switch, would be located near the transformer and easily accessible. The switch would be clearly labeled to indicate its purpose. In each of these scenarios, the fundamental principles of Section 450.13 and be applied. The transformer must be capable of being disconnected from all ungrounded conductors, and the disconnecting means must either be within sight or capable of being locked in the open position. The specific implementation will vary depending on the size of the transformer, the location, and the applicable codes and regulations. When designing a transformer installation, it's important to consider the accessibility of the disconnecting means. It should be located in a place where it can be easily reached and operated even in emergency situations. The disconnecting means should also be protected from physical damage and environmental factors that could affect its performance. For example, in areas where there is a risk of flooding, the disconnecting means should be located above the floodplain. Similarly, in areas where there is a risk of vandalism, the disconnecting means should be protected by a secure enclosure. The use of appropriate signage is also crucial. Clear and concise labels should be used to identify the disconnecting means and the equipment it serves. Warning signs should be posted to alert personnel to the potential hazards associated with transformers. Regular training and drills can help to ensure that personnel are familiar with the location and operation of the disconnecting means and the proper lockout/tagout procedures. This can be especially important in emergency situations where quick action is required. Ultimately, the goal is to create a safe and reliable electrical system that protects personnel and equipment from harm. By carefully considering the requirements for transformer disconnects and implementing appropriate safety measures, you can help to achieve this goal.